I said, chapter 4, it's going to be more challenging. You're going to have to think. You're going to have to evaluate. It's not just do the same thing. Every problem is the same. If you're a cookie cutter master, this isn't going to work for you. So this is the book. Obviously, this is the book starting off with parent function of y equals x squared. We're going to go a little bit different. We'll go back to quadratic functions. 3 different forms that you need to be comfortable with. All right? 3 different forms. The first one we usually work is standard form. This is also, bless you, written as a polynomial. And when it's written as a polynomial, the highest power on the variable has to be a 2, which it is right here, in order to be in standard form. Standard form, ax squared plus bx plus c, there's no limitations on a, b, and c here. This is not a line, it's a quadratic. What does quadratic tell you? When we say the word quadratic, what are we telling you? It seems like it should be 4, but it's not. What does quadratic tell you? It's a parabola. That's one thing you know for sure. So what else is it telling you? If you know it's a parabola, what do you know about the function? What does quadratic mean? Maybe, but all types of functions you may want to factor. What is the difference between quadratic, cubic, quartic, quintic? What is quadratic telling you?
4 radix.
This is a quadratic function in standard form. What is a quadratic function telling you? Wow, you guys, church is not your thing, I can see. The highest power on the variable has to be a 2. That's what we're telling you when we say we have a quadratic function. Quadratic means power of 2 on the variable when you're in polynomial form. What is this power also called? Anyone remember what this is called? The highest power on the variable also tells you something else about the polynomial. Begins with D, ends in degree. The degree, very good. Some of you will get better at that game than you want. If it's a degree 2, quadratic function. If it's a degree 2, what else do you know? Anyone know what the degree tells you, the highest power? Tells you how many x-intercepts you have. How many x-intercepts are there? 2, always. There's always 2 x-intercepts. Now sometimes those x-intercepts are imaginary. Sometimes it's a double x-intercept. But there's always 2 that are x-intercepts.
I was going to say, so what if it's like a phone?
Yeah, then you have the imaginary, and if it's on, if it just comes down and kisses, then it's going to be a 1, but it's called a double. So all those types of details you have to know. You can no longer sit here and say, oh, those details don't matter. They do, and they come up on the test. And why do people bomb the test? They don't study every night, and they totally blow off the details. Quadratics, power of 2. Parent graphs. All right, we're on our second parent graph here. We did absolute value of x. Now we're doing x squared. Y equals x squared. The parent graph is a parabola. You see this blue shape right here, that's a parabola. The parabola starts at the origin, and an origin is a point on the graph. And from that point, we go right 1, up 1. Right 2, up 4, right 3, up 9. If you remember back to the absolute values, I told you, whatever you do when you go right, just apply the function to that, and that tells you what to do in terms of up or down. So if I go right 1, 1 squared, we square the 1, we get up 1. We square the 2, you get up 4. Square the 3, you get up 9. On the other side of the origin, if you go left 1, when you square negative 1, you go up 1. Left 2, up 4, left 3, up 9. If you have a quadratic, your shape is always, always, always going to be a parabola. It's always going to be a parabola. What did I tell you about absolute value functions? Always a V. In almost everybody, except for 2 or 3 people, can graph absolute values and get a V shape. But we still have 3 people who can't do that. Anytime you have a quadratic, you have to get a parabola. In this class, the parabola has to either open up, like this one, or open down. It can't open sideways. Not in this class. Please memorize this tonight. You need to be dialed on the parent graph. Bless you. Now, the other component that they really spend a lot of time on in this chapter with parabolas is called the axis of symmetry. An axis of symmetry, what does symmetry mean?
Equal on both sides.
Equal on both sides, right? Well, if you look at certain things, there's symmetry all over the place. Symmetry in nature. So when one of my sons, my youngest son, was in preschool, he made this butterfly right here. It's been hanging here a long time. And he used this stuff called dot paint. I don't know if you remember dot paint from when you were a kid. Dot paint were these bottles of paint with the spongy top, right? And so he put the dots on one side and then fold the paper, open it up, and it's the same on both sides. And then we have the line down the middle. That's the line of symmetry for the butterfly. And you can see symmetry in nature all over the place. And then he wrote his poem on the back. If I was a butterfly, I would soar through the sky and ride with the wind. If I were a butterfly up in the sky, I would look down and everything would look like ants. If I were a butterfly, I would dive at the ground and soar back up to the sky. Pretty advanced for a preschool kid. His writing is perfect, too. Yeah, better than mine. People, we're pretty symmetric down the middle. We're not identical on both sides. And sometimes in some classes we take faces, cut them in half, and you put them back together, and the people look very strange when you do that. So we're not totally symmetric. 3 forms of quadratic equations. First one, standard form. From standard form, we know a whole bunch of stuff. Remember back, here's our parent graph though, right here. Y equals x squared, and the line of symmetry right here is this dotted yellow line. It is not part of the graph, it's imaginary. What kind of a line is this line right here? Yes, what else? What kind of a line is this?
Vertical.
Vertical. How do you write the equation of every vertical line? Vertical line. X equals whatever x is equal to, in this case, 0. So the axis of symmetry has an equation of x equals 0. Be really careful of that. Because when I ask for the axis of symmetry, a lot of people will just say, oh, it's 0. It can't be. It's a linear equation. It has to be x equals because it's a vertical line. What point on the graph does it always go through? In the parent graph, it'll be the origin. Need to stand? Sure?
Yeah.
Uh-huh. What point is this? Yeah, that's on this graph. What's it called on a parabola?
Axis.
The vertex. It's always going to go through the vertex. We have a bunch of ways of finding the vertex depending upon what form you're in. In standard form, here's how we find the x-coordinate of the vertex. Opposite of b over 2a. The opposite of b over 2 times a is the x-coordinate of your vertex. That means that every axis of symmetry equation has to be x equals what? What does x have to equal for the equation of the axis of symmetry for every quadratic equation? What point does the axis of symmetry go through? No, that's just the parent graph. Okay, we'll come back to it. We'll see if you can figure it out. So the vertex is the opposite of b over 2a. That's the x-coordinate of the vertex. How do I find the y-coordinate of the vertex?
Plug it in.
Plug the x in, and you'll get y. So we take whatever number this turns out to be and put it in for x, and you solve for y. So if opposite of b over 2a gives you the number 2, you'd plug in 2 here for x and 2 here for x, and you'd solve for y. In other words, you're kind of using this idea of a t-chart, but you're only doing it for the vertex. Back to the idea of a translation vector, the vertex, the x-coordinate of your vertex is c, and the y-coordinate of your vertex is d when we identify the translation vector. A, still the vertical stretch vector. Remember, we multiply the ups from your parent graph by whatever your vertical stretch factor is. Okay? Remember, here are your ups. Up 1, up 4, up 9. Up 1, up 4, up 9. That's what you're going to multiply the vertical stretch factor by. Here's my parabola. If I move it to this point right here, the axis of symmetry goes to here. What is the equation of the axis of symmetry?
X equals 4.
X equals 4. What is the coordinates of the vertex?
4, 0.
Not 4, 0.
Makes 4, 2.
4, 2. And the axis of symmetry was x equals 4. If the parabola moves to, let's say, right here, what's the coordinates of the vertex? Can you see that? 6, negative 1. What's the equation of the axis of symmetry?
X equals 6.
X equals 6. We'll do one more over here. Move it to right here. What's the coordinates of the vertex? Negative 4, 4. The red lines are worth 2. So up 2, 4, and left 2, 4. So negative 4, 4. What's the equation of the axis of symmetry? X equals negative 4. What are you finding out that the axis of symmetry always passes through the vertex? How do you write the equation of the axis of symmetry? X equals
Something.
the what? The x-coordinate of the vertex. Whatever your x-coordinate of the vertex is, the opposite of b over 2a, you automatically know the axis of symmetry. So when you have standard form, opposite of b over 2a, not only does it give you the x-coordinate of the vertex, but it also tells you the equation of the axis of symmetry will be x equals opposite of b over 2a. Has to be written x equals. On the test, there is a section where I say, here's the equation, what is the vertex, what are the x-intercepts, and what is the axis of symmetry. Some of you are going to write down the axis of symmetry as 2, or 7, or 9, or negative 4. It can't be. It has to be an equation. And it's always x equals opposite of b over 2a. Now remember, your vertical stretch factor for a parabola, just like absolute values, if it's positive, it's going to open up. Guaranteed. And if it's negative, if the vertical stretch factor is negative, it's going to open down like a frown. If it's positive, it opens up like a smile. If it's negative, it's opening down like a frown or a rainbow. The vertex, when you're opening down like a rainbow, is called the maximum point for the graph. It is the biggest y value you can get. Whereas on a smile, it's the lowest point on the graph. It's the smallest y, and it's called a minimum. The graph cannot go any lower than that point. It's at the bottom of the valley. Whereas on a maximum, it's at the top of the mountain. That's why they're called maximums. And the thing that is maximized or minimized is not the x, it's the y. It's not the x, it's the y. Anybody have any questions on this so far? You should be seeing lots of similarities between the parabola and the absolute value. Opens up, opens down. A is your vertical stretch factor still, and that determines everything about the stretch. And we don't have to worry about horizontal stretch factors because in standard form there isn't going to be one.
So for the vertex, when it says plug x into the equation, what is x?
Opposite of b over 2a. Once you take this, take the opposite of this over 2 times this, you're going to have a number. Let's say it was 5. That means the vertex will be 5, comma. How do I find out what goes after the comma? Plug in the 5 for x. It's hard to do in generic like this. We'll do an example here shortly, and we're going to ramp up the examples.
What is ax squared? What is that, like, the squared part of the equation?
Y equals 2x squared minus 5x plus 1. That's standard form. This is A, this is B, this is C.
Okay. And then when you plug it back into the vertex equation, what do you like distribute?
We're going to do the opposite of negative 5 over 2 times 2. This isn't a really good example.
So you don't do the power of 2? What is the power of 2?
That's what you do to the x. You square it, times it by 2, then subtract 5 times whatever the x is, and then add 1. We don't do anything with this here.
Yeah.
Is that what you're asking?
Yeah. What do you
Do you see any x's in here?
Well, no.
No. This is x is a variable. X is a variable, y is a variable. Look. A, B, and C are numbers. To find out what the x-coordinate of the vertex is, this is what we're going to do. What are you finding? You're finding the x-coordinate of your vertex.
So that equals x,
When you go like that, it's hard for me to see what you're pointing at.
the vertex.
The opposite of b over 2a. This really isn't meant to be an equation. You could do it as an equation. If you did, you would say the x-coordinate of your vertex is the opposite of b over 2a.
Yeah.
Okay? But you're finding half of the coordinates of a point. The x-coordinate of a point, a very specific point. And it's the point called the vertex. That means it's either the lowest point, or if it's a horseshoe down, the highest point. But all you're finding is x. If I tell you x is 1, how do you figure out what y is?
Plug x.
You plug a 1 in where you see the x.
Yeah.
If I tell you x is 2, and I want to know what y is, what do? Plug a 2 in for x. And you could do that for any value of x you want. But it's going to take you days to graph. So rather than do that kind of stuff, I'm telling you the most important point, here's how you find x. Once you know the x, plug her in and you got y. Does that make sense?
Yeah. And then, I guess you have to go out there, yes, but when you do get x, and then you multiply x times 2 and then the power of 2.
What are the order of operations telling you to do? Do you square first or multiply first?
You square.
You square first, then multiply.
Okay.
Parentheses, exponents, multiply, divide, add, subtract. Please excuse my dear Aunt Sally, right? You don't want to go against those rules, because otherwise they're going to blow up. Now, this is not related to standard form. This is what we talked about earlier, and it's our second form of a parabola, and we'll get to that shortly. But I want to remind you these things. You have this in your notes already. If you were in this form, a times f of b times x minus c plus d, then you would already know the vertex. It would be c comma d right here. A is still your vertical stretch factor. And if there was a b inside the parentheses that you were squaring, 1 over b would be the horizontal stretch factor, but again, you really don't need to worry about those at this point.
If you already know the x coordinates for the vertex, because all you have to do is plug in c, right?
No, c is the x coordinate in the vertex.
So then why would you do negative b over 2a, or b?
Because this c, this b, and this d, and this a are not this a, b, and c.
Right.
This is not, do you see how this is not? Here, let me steal it. See how this is not in the form of red?
Yeah.
It doesn't have parentheses, x minus something squared plus something.
Yeah.
This is standard form. This a, b, and c are not this a, b, and c.
Oh, okay.
They're the same letter. These are capitals, these are lowercase. They're not the same. They're not in that
So in
form.
standard you have to do the b over negative.
Correct, that's what I'm telling you.
In this form you have to, in this form you just plug in c and d.
Yeah, this is just a reminder. We're not to another form yet. This is just to remind you from chapter 2 when we did absolute values. This was the Rosetta Stone for graphing. Okay? We're going to get there, but we're not there yet. And CD is your translation vector. You're moving the origin. These are the exact notes from chapter 2. You know how I know? I just copy it and paste it. So nothing new here. Okay? So let me take you through a couple of graphs and let you see what's going to happen. We'll start off really easy with no bx or c, and then we'll add those components as we go. I expect to see what I keep calling the list. When you graph, you make the list. You don't make the list, -1 every time. Make your list. In this particular function, b is 0 and c is 0. All we're doing is multiplying something times the parent graph. What is the parent graph for this function? Y equals x squared. How do you know it's not absolute value of x? There's no absolute value signs around the x. It's not a mystery. What function are we doing to the x we're squaring? Parent graph. Translation vector. 0, 0. What else is 0, 0 going to be called? A vertex. A translation vector is also the same coordinates as your vertex. If you list it as a vertex, put it in parentheses. 0, 0 with parentheses. But we're listing it here as a vector. I will take either on the parabola. Vertical stretch factor. 1/2. The axis of symmetry has to have an equation of x equals 0. The x-intercepts are going to be important to us. They're not important that you know what they are at this stage. You'll be able to tell when we look at the graph. We're not translating, so we start at the origin. In the parent graph, we go right 1, up 1. What are we going to do? We're going to go right 1, up 1/2. Bless you. Right 2 in the parent graph, up 4. We're going to go right 2, up 2. And in the parent graph, right 3, up 9. We're going to go right 3, up 4.5. Now, if you're not getting how I'm getting those points, you should be like this right now. I don't get it.
I don't understand how you got right one and then up 1/2.
Okay? Remember the vertical stretch factor, we're going to multiply the ups, whatever you say after the word up in the parent graph. In this example, what's the vertical stretch factor? 1/2. So after, whatever I say after the word up, you're going to times it by 1/2. Look here, right 1, up 1. Right 2, up 4. Right 2, up 2. And right 3, up 9. Right 3, up 4.5.
So do we just square those if there's no vertical stretch factor? Do we just square the right? Because it says right 2.
Up 4?
Up 4.
I want you to memorize this. I want this memorized. How am I getting these numbers? I'm squaring these numbers, absolutely. But I want you to know this as good as you know your own name. So when we go to our example, I want you to be able to go right 1, up 1, becomes right 1 up 1/2, right 2 up 2, and right 3 up 4.5.
Since you times 1/2, are 2 right?
We're going to go right 1, this is the parent graph, right? Right 1, up 1. Oops. Get it?
I get the parent graph.
Okay. After the word up, what number appeared? 1. Multiply the up by 1/2.
Okay, so I get the right one up 1/2.
Okay, I didn't understand your question.
Okay, then you go right 2, then instead of going up 2, you go
In the parent graph, what do? Right 2, up.
2.
In the parent graph.
Oh, 4. Oh, okay. Gotcha.
Do you have it written down wrong?
No, I get it.
You sure?
I get the other parent graph. I get it.
Okay. And then it would be identical on the left side. Left 1 up 1/2, left 2 up 2, and left 3 up 4.5. Your graph needs to be a nice smooth curve when it hits the vertex. It may not be done with a ruler, and you need to make sure it flattens out as you get to that vertex. If you do a poor job graphing, I'll mark it down. I've had kids connect these with rulers. Don't do that. It's not string art. It's a nice smooth curve. As you approach the vertex, you flatten out. And then come out flat and go up the other way. What is the equation of the axis of symmetry? X equals 0. How do we show it on a graph? With a vertical, highlighted, dotted line. It's got to be x comma y, right? It's got to be an ordered pair. So if I ask you for the y-intercept, you need to have an ordered pair. Now what is the y-intercept for this graph? 0, 0. How do you know? Just look at it. What is an x-intercept for a graph? Where does it cross the x-axis? In this case, the x-intercept is also 0, 0. How do we know? We just look at it. But you need to list it as an ordered pair. Now it should be obvious to you that not all parabolas will be at the origin. And all x-intercepts will not be the origin. Is anyone not seeing how we got the x-intercept? Okay. So now we have 3x squared. Try that. All right, let's look. What's the parent graph? Y equals x squared. Translation vector, we already said, has to be 0, 0 because there's no bx and there's no c. Jim, what's the vertical stretch factor? 3. And the axis of symmetry has to have an equation of x equals 0. And we know that the x-intercept, hopefully you know, is going to be 0, 0 as an ordered pair. And you might not know that right now, and that doesn't bother me at all. This is an inconsequential fact at the moment. But when we do our graph, we plot points, we start at the origin. parent graph is right one, up one. What are we going to do? Up 3. Right 2, up 12. So for me, I'm a little bit higher than my grid. Left 1. What do you do in the parent graph? Right 2, up how many, Riley? Is it you who had the question? Why is it up 12? Who asked why is it up 12?
Oh, I did. I just.
You good? Right 2, up 4.
4 times 3.
4 times 3 is up 12. So left 2 also up 12. This parabola, very tall and skinny parabola. And then you can take a look and see, there's my x-intercept at 0, 0. And there's my dotted, highlighted axis of symmetry.
Would the axis of symmetry, would that ever be a solid line?
No, it's imaginary. These points are not part of our graph. It's just an imaginary line where if I could fold the paper on that line, this side would match right on here. So this point would land there, this point would land right there, this point would land right there, and so forth. It's perfectly symmetric. Okay? What's going to happen to this graph?
Go down.
Okay, let's do this one together. What's the parent graph?
Y equals x squared.
X squared. What's the translation vector? 0, 0. All three of these 0, 0. But the vertical stretch factor is now negative 2. Axis of symmetry is still x equals 0. And we're still at 0, 0. So instead of right 1, up 1, we're going to go right 1, down 2. And instead of going right 2, up 4, we're going to go right 2, down 8. And left 1, down 2, left 2, down 8. Flush. And that's what your graph is going to look like. And your axis of symmetry go right through the vertex every single time. It will be done with a highlighter and it will be dotted always. Any questions so far? Let's translate a little now. Okay, we're going to translate just a little bit. And we're looking at 2x squared plus 4. We're in standard form. What's b in this equation?
4.
What's b?
2. 0.
4.
Remember, ax squared plus b times x. What am I multiplying by the x here? 0. It's gone. It's not even visible. C is always your constant, just your flat out plus or minus number. Does that make sense?
Yeah.
So the parent graph is y equals x squared. If b is 0, the opposite of b over 2a, when b is 0, is going to be the opposite of 0 over 2 times, in this case, negative 2. When b is 0, the x-coordinate of your vertex will always be
0.
0. And when you plug a 0 in for x, this term disappears. What's y?
4.
4. Easy. Am I going too fast with that? If we plug in a 0 for x, x squared, that's going to become 0. 0 plus 4 is 4.
And C is Y?
C is C.
If you get 0, 4.
Correct. When you plug in a 0, you get 4. No. Only when b is 0 will c equal y. You're talking about y for the vertex.
Yeah.
Yes. When b is 0, the vertex will be 0, comma c. I don't think you want to start trying to come up with a way to remember every single peculiar event. That's a peculiar event. Opposite of b over 2a gives you 0. Plug in the 0, you get the 4c. If you can remember it's 0c when b is 0, awesome. Vertical stretch factor, -2. Axis of symmetry is x equals, and the x-intercept is going to become, we don't know. And we're going to wait and see. So when we graph this, we start at 0, 4. We move the origin up 4 units. From our new origin, the parent graph would tell you to go right 1, up 1. We have a vertical stretch of -2. We're going to go right 1, down 2. From the new origin. In the parent graph, we would normally go right 2, up 4. We're going to go right 2, down 8. Then we're going to go left 1, down 2, and left 2, down 8. And we're going to get this graph. Same shape as the one we just did a minute ago, but moved up 4 units. We're still x equals 0. Now take a look at the x-intercepts on this. Can you tell what they are? Kind of, but you can't be sure. It's somewhere between 1 and 2, and somewhere between -1 and -2.
I have a question. When you go right, left 1, down 2, and then aren't you supposed to go left 2, down 8?
I did. Left 2, down 8. Did I not go down 8? Left 2, 1, 2, 3, 4, 5, 6, 7, 8.
I did stuff. No, not that. The red one.
Are you with me?
Yeah,
Okay. I can make the points bigger if you want. Everybody okay with that? Okay, now let's see what happens when we have an ax squared, a bx in the C. Yes. We're not, like I said,
You don't have to find them.
I've-
You can't figure it
well, of course we're going to have to find them. Right now, we don't have the skill to find them.
out.
We can only do so much by looking. It's between 1 and 2, comma 0. Between -1 and -2, comma 0. This is here. We'll deal with it. Be patient. And women, I don't know. Patience. Patience. If you can tell where it is, like if the point lands nice and pretty, we're good to go. But we have to have some other things. And you already know how to do it. You just don't know that you know how to do this yet. Okay? And we'll go to this. So now we're looking at standard form. When we make our list, we can say right now, what's the parent graph?
Y equals x squared.
Y equals x squared. Dana, do you know the translation vector from looking at the equation? No. Can't tell just by looking at the equation. How about the vertical stretch factor? Do you know that, Dana?
0.
Don't listen to the studio audience. They just shout anything. They're the same people on the street yelling to that guy to jump. So, what's the vertical stretch factor? 1. Because that's A. Imaginary 1. Axis of symmetry. We don't know yet. And we don't know the x-intercepts yet. Let's go back to our translation vector / vertex. How do we find the x-coordinate of the vertex? -b over 2a. If you write it down for tonight's homework, you'll for sure know it tomorrow. What's b? B is not 2. B is -2. What's a? 1. The kids who get it wrong will do this in their head. Okay, and they're going to make mistakes with it. The opposite of -2 is 2 over 2. X coordinate of your vertex is 1. Write it down. Don't be in a position to make a careless arithmetic mistake because you want to do this in your head. It's not worth it. It's the opposite of B over 2 times A, and that's, again, that's the key. That's why I always write it down, and I don't simplify in my head. Because I always get the negative one is the mistake answer. How do I find out what the y coordinate of the vertex is? Plug in the x. How do I do that? I write it down. Y equals 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8 would be negative 9. 1, negative 9 is your vertex / translation vector. Take a look at that. See if there's anything you're not getting.
So if the x didn't equal 1 and it equaled like 2,
Yeah.
then would it be 4 minus 2?
Well, again, see what I'm doing right here?
Yeah.
This is plugging it in.
So, but, okay, yeah.
If there's a 2 here, you would square the 2.
Okay.
You would then multiply 2 times 2, and you'd subtract it from whatever you got here, and then you'd subtract 8. But doing it in your head, not recommended. All right? Axis of symmetry has to be x equals 1. Has to be. So if we're going to graph this, we're going to start at 1, negative 9. 1, 2, 4, 6, 8, 9. 1, negative 9, way down here. Parent graph, right 1. In this graph, we're going to go right 1. That wasn't very convincing. Say it again. How'd it go? Right 2, up. Right 2, up. And right 3, up. 9. Left 1, up 1, left 2, and left 3. So when we make our graph, you get a picture that looks more or less like that. Here's my axis of symmetry dotted. And now, if I say, well, can you tell me the x-intercepts? What are they? 4, 0, and negative 2, 0. 4, 0, negative 2, 0. Have to be ordered pairs. It's the 2 points where the graph crosses the x-axis. The 2 points, sometimes there's only one, and as was pointed out, sometimes there's none. But in this case, there's 2. Questions? Here we go. So properties, we've talked about these. What controls up or down? The vertical stretch factor. It's A controls up or down. When A is positive, you'll horseshoe up. When A is negative, you'll horseshoe down. Okay? So these are book notes. We've already looked at them. Let's look at another graph. Be careful with this one. Give this nice harmony on that. So now what you get for a parent graph? Y equals x squared. And what did you come up with for the translation vector? 3, 1. Is anyone not clear on how to get the 3, 1 for the vertex or translation vector? If you're not, go like this. We'll take a look. Did you get 3? Okay. Well, let's try it. So x coordinate of vertex is the opposite of 6 over 2 times negative 1. That would be the opposite of 6 over negative 2, which is positive 3. When we plug in, here's the way my plug-in looks. Now, order of operations. Remember PEMDAS. Right? Parentheses, exponents, multiply, divide, add, subtract. Please excuse my dear Aunt Sally. This is multiplication. If it helps, you can make this negative 1 times 3 squared. What do you do first? Do you multiply or square? You square first. Exponents before you multiply. That's going to give you negative 9 plus 18 minus 8. that's going to give you 9 minus 8 is 1. Now, you probably did negative 3 squared and got 9, plus 9 is 18, minus 8 is 10. Or 9 plus 18 is 27, minus 8 is 19. Whatever it was you got. What's the vertical stretch factor? Careful.
-1.
-1. Axis of symmetry has to be x equals 3, and we'll find the x-intercepts later. Okay, so 3, 1, right here. In the parent graph, it's right 1, up 1. What are we going to do? Right 1, down 1. And left 1, down 1. Right 2, down
4.
and left 2, down 4. So my graph is going to look like that. Here's my axis of symmetry. And I now can identify my x-intercepts. What are they? Now you can't always see them, so just leave it blank for now.
Does it matter which order we put those?
Nah, doesn't matter to me. I usually try to go left to right, but even I don't do that. Sometimes I forget. Let's start over.
It doesn't cross over X.
The x-axis?
Yeah.
Okay.
Then it's 0, 0.
The what 0? If it goes through 0, 0, it's 0, 0.
Oh, but if it doesn't go through anything, then
Like if it was this parabola,
yeah.
no x-intercept.
Okay.
But if it's this parabola, the x-intercept's the origin.
Okay.
Okay?
Do you want us only to do the x-intercepts?
Well,
So like, whatever. X.
this is my list right here in blue. All the time, no tricks. They will ask you for the y-intercept on occasion, but it's not a critical point for me.
Okay.
I could care less. I'm recording. I really think the y-intercept is very important, but we're just not going to write it down. How about that? Okay? You got to pay attention here. We go really fast in here. Oh my gosh! What? What? Go online, YouTube. Put my name in, no space. You'll get this tonight. You can relive this whole class. Wouldn't that be fun? Oh, hey, I'm telling you, it makes, for those of you who are going to start struggling, you go back, you get to re-listen and see the details again. It makes a difference for you. It'll help. In this class right now, until you hear me say, okay, today we're going to use, we're only going to have verticals. And in standard form, we only worry about the vertical. Okay? What's the parent graph on this one? Vertical stretch factor. X coordinate of my vertex is the opposite of 6 over 2 times 2. So we're going to end up with negative 3 over 2 for the x-coordinate vertex. Folks, you're not always going to have a nice, pretty vertex. Deal with it. Okay? The whining about it isn't going to change the vertex. It's negative 3 over 2. Bless you. That means x equals negative 3 over 2 is automatically my axis of symmetry. So we can go right at it. X equals negative 3 over 2. Okay, guaranteed. How do I find y? Plug the x in. When it's not pretty, you better really be cautious with your plug-in. Use parentheses. Don't skip steps. You don't really need a calculator to square 3 and square 2 to get 9 over 4. Minus 9 plus 3. If I'm going too fast, raise your hand. Okay, I want you to make sure you can go through this too. This is going to equal 9 over 2 minus 18 over 2 plus 6 over 2. Now I know that I need a common denominator, so I just switched them all to over 2s. 9 is 18 over 2, 3 is 6 over 2. I'm just planning ahead to save writing. I know how important save the lead is around here, or save the ink foundation. Think of all the ink we'll save, even virtual ink. So 9 over 2 minus 18 over 2 is negative 9 over 2, plus 6 over 2 would be negative 3 over 2. So my vertex is negative 3 over 2, negative 3 over 2. Yeah, did I make a mistake? We good? So we're right here. Negative 1.5, negative 1.5. Which way does it open? Why do you think that?
Opens up.
Wait, that's not what you said.
No, because it's positive, not negative for the x squared.
But you said yeah. But you meant no. Alrighty. Now, be really careful with how we're doing our counting. We're counting boxes. So when we go right 1, we're in the middle of this box. How many up do I go? If we have a vertical stretch of 2. Right 1, up, 1, 2 puts me right here. Left 1, up 2. Right 2, 1, 2, up 8. And left 2, also up 8. Can you find your x-intercepts? In standard form, the y-intercept is always going to be what? In standard form, what's the y-intercept always going to be? The y-intercept. Y-intercept will always be 0, c. So it's going to go through this point right here. Is that important? Is that important, Bryce? No. I mean, it's a point on there, but we just had that conversation 5 minutes ago. The y-intercept is something that they might ask you for, but I don't need it in your list. But it can give you another point on the graph and it helps you make sure, hey, my graph's right, because it's going through 0, 3 right here. X-intercepts, we're not going to get them on this one. Okay? We already talked about maximum and minimums. Okay? Now, this is the phrasing of this question is important because on the test and on the quiz, I ask you, what is the maximum or minimum value? Does anyone have any idea what I'm asking for? More specific than that.
The y.
The y of the vertex. That's all I want to know. What's the maximum value of this function? See who's been paying attention. Because b is 0, the vertex is at 0, 3. 3 is the biggest value we can get for y. Anything up higher, not going to happen.
So is this no word problem?
No, on this is a no work problem, but this is not. So what we're going to need to do is find the x-coordinate of the vertex. The opposite of negative 6 over 2 times 2. So we end up with 3 over 2. How do we find the maximum value of the function?
Plug it in.
Plug it in. It's the y, fumble. It's It's the y value of the vertex. So we're going to take the x, and we're going to plug in 3 over 2. Now, there are people in this room, and I don't want to know who they are right now, but there are people in this room who cannot simplify this, even with a calculator. I want answers in fractions that are reduced, not mixed numbers. And I expect that you can do this math. If you need help with your fractions, please come in as quick as possible. So very similar to what we just did, we have 9 over 2 minus 18 over 2 plus 12 over 2. So we're going to do 9 minus 18 is negative 9 plus 12. Coincidentally gives us 3 over 2. It does not always work that way.
When we do the maximum minimum, do we have to do y equals, or can we just do?
Well, the question says, what's the maximum value of this function? Your answer is simply 3 over 2 is the minimum value. On this one, that's a great question. This one's a max. How do you know?
If the a is positive.
If a is negative, it's this way, right? So this is a maximum. If a is positive, then we have to be looking at a parabola like this. This has to be the minimum value. Great question. You know what we're doing there. Harry Potter, conducting. Got something going there. Everybody good? The last thing that you need to be able to do is take application problems from words to equations to answering the question. The biggest problem that I run into is not answering the question answers and not knowing what the question is asking. Okay? What kind of a function are we going to create? Quadratic. You know why? Because that's what this section is. It's all about quadratic. So if you get something other than a quadratic, well, something's amiss. So revenue. One of the things you should be able to do is come up with revenue. A sports store sells about 50 mountain bikes per month at a price of $220 each. For each $20 decrease in price, they're going to sell 10 more bikes per month. And we want you to just write the function in standard form that models the revenue. How do you find revenue? This is an important question because it keeps coming up. How do we find revenue for a company? It doesn't, just in general, how do you determine the revenue? You sell needs. How do they figure out the revenue?
You take it, or you subtract how much you spend, get what you sold for like.
Not for revenue is how much money's in the cash register at the end of the day, assuming you started with 0. How do you determine your revenue? Nope.
What you sold times by how much it costs.
How much you sold times how much they cost. Number sold times cost. Simple as that. Number sold times cost. The unknown in this problem is what? What is the unknown? Revenue is one of the unknowns. What's the other unknown?
How many bikes per month?
Nope, we know how many. We sell 50 a month at $220 each. Nope, don't care. You're thinking about profit, and we're just talking revenue. The other unknown is the number of $20 decreases we're going to apply. We don't know what we're going to set the price at. We're trying to increase our sales. So we're going to lower the price of the bike. When you lower the price of the bike, what happens to your sales? They go up. And in this case, they go up by 10 a month. So, if X is the number of $20 decreases, how many mountain bikes will you sell? How many bikes will you sell if we lower the price by X dollars? I'm sorry? I'm sorry, X number of $20 decreases. I'm sorry? No, we know exactly what it will be. I mean, it'll have a variable. The variable is X. If I decrease the price by $20, so X is 1, what will the cost of the bike be? $200. Does everybody see that?
Yeah.
If I decrease the price by two $20 decreases, in other words, $40, how many bikes, or what will the cost of the bike be? $180. How do I find the cost of the bike? From, which is, and how many times do I do that?
How many times X is?
No, but X is X. So how many times? X times. So 220 minus 20X. That will give you your cost. Using the same logic, yeah, and I wrote it for bikes sold, right? That's our cost. So using the same logic, how many bikes sold? Using the same logic, how many bikes am I going to sell? Well, I didn't hear you. So I can't just write a floating plus 10 out there. How many bikes, not what's the cost? Number of bikes sold. Not 60.
50 plus 10.
50 is your starting amount, and for every X, we're going to increase by 10. 50 plus 10X. And let's call R the revenue. This let statement is the hardest part. Now we just plug into this formula. What's the equation going to be for revenue? R equals 50 plus 10X times 20X. Very good. Is this in standard form?
No, yes.
You've got to multiply it out. Whether that's FOIL or monkey method, whatever it is you do, you better have a way that you can multiply these. Okay? What's 50 times 220?
11,000.
We're going to get 2200X minus 2000X will be plus 200X in the middle, and then minus 200X squared on the end. Is that standard form?
Yes.
It's backwards. Very good. R is going to equal negative 200X squared plus 200X plus 11,000. Sorry. That middle number's got to be wrong, right? Yeah, I'm off. I'm in the hundreds. It should be thousands. So 2200 minus 2,000. Oh, 200. We're okay. That's your function right here. These are challenging. You have to think. There are going to be questions that aren't this question on the test. You have to be able to adapt to that. We didn't do one like that on the homework. They're going to be different. Right?